Just, can you introduce yourself, Jess?
Yeah, my name is Kelsey McCloche. I'm a PhD in statistics and I work with the Jump Genomics development. I'm a developer for that group. I develop our analytical processes, which are statistical methods and platforms for doing specific genomic analysis. Jump Genomics is a bundled product of both Jump and SAS, as well as a suite of macro code that we have written for these specific genomic analysis, including genome-wide SNP association data and gene expression data, so microarrays and things like that. We also have a little bit for proteomics. We also have some really advanced statistical capabilities for predictive modeling, as well as things for doing mixed models and lots of drill downs and row-by-row modeling to look at ANOVAs across each gene.
Okay, so let's see it. Okay, can you show?
So this right now is actually another product that I'm showing, which is Jump Clinical, which is another bundled product that combines SAS with Jump. So if there's any people doing safety analysis and beginning of some of the clinical trials, like stage 1 and stage 2, we have quite a bit of things for that in our new product that's coming out this summer. Let me start fresh. This is our current release of Jump Genomics 4.1, and what this bundled product gives you is an additional menu to the typical Jump menu. So Jump would be all these items except for Jump Genomics and the clinical, which give you lots of options for doing analyses and visualization graphics. The Jump Genomics menu, all of our analytical processes are kept through this menu. And the first part is ways for importing your data. If you're familiar with different genomics companies like Affymetrix, Illumina, we are partners with them so we can handle their imports to get your data into Jump Genomics.
Yeah.
The format would be a SAS data set. We also have some workflows to help get you started. So if you're interested in, say, doing a basic expression workflow, say you have microarray gene expression data, we have all these workflows that are custom Jump dialogues. And we have saved settings that actually save out SAS programs that you can load, and you can see what your data looks like. So here we have gene expression measurements across samples for Drosophila data. And you can specify variables you want, as well as your experimental design, which tells you what the design of your experiment was, where the samples came from. Here we have flies that are of different lines, male and female sex, and from different age groups. And we have gene expression measurements over all those design factors. We have lots of different ways to do quality control and normalization methods for expression data, as well as for SNP data, like distribution analyses, lots of correlation principal components, and then you can fit your ANOVA model here to test for differential gene expression. We also offer lots of multiple testing because we are doing many tests with this. So let me set this running. And what you're going to see flashing up, again, this is just one of our basic workflows, and it's tying together lots of our processes. So we're going to launch each one, and it's going to run through each one. We're connecting to SAS in the background and running our SAS program. So these are macros that we've developed. And once this is finished, we'll have what's called a Jump journal. So we take advantage of as many of the Jump features as we can, including the journaling capabilities and the interactive graphics. So even though we're connecting to SAS and we're using SAS datasets, we bring the results back to Jump, open it as a Jump table, and then we can do the graphics that we are offered through Jump. This is a very live demo.
Yeah.
And this is the last step. We've done our QC and normalization, and now we're loading up our ANOVA platform, and that's connecting to SAS in the background and running that to test for gene expression differences in our data. Now here's our results, so we can see all the processes we did. And each time we click on the button, it'll give us the results of that process. This first one was just a quality control to look at our data. So we're taking advantage of the parallel plot platform that's available in Jump through the graph menu as parallel plot to plot the distribution of the gene expression intensities for each sample from our experimental design set. And we've colored by sex, which seems to be a very good differentiator between the two groups. Notice the interactivity of these graphs. You can do selection, and we have drill down possibilities for things where you can actually remove bad quality arrays from your data before you continue on. let me go to the next one. Then one of the next one was again a quality control thing where we're looking at the correlation of the arrays across all of our samples. And again, we have different drill downs that you can use to guide your analysis. We also again are taking advantage of JMP's 3D scatter plot, which is a nice interactive thing, and it still has the capability to do selections. Anytime in JMP when you make a selection in a graph, everything is dynamically linked, including to other graphics as well as to the data set. So if you actually look at the data set, you can see we've selected those rows. So when we change our selection, it changes the selection of rows dynamically and automatically. It's really easy to do data manipulation this way in JMP because when you have a selection, maybe you're interested in drilling down on that set, you can just go up to tables, subset, you know you have rows selected, click OK, and now you have that subset of selected rows from your table. Continuing on in this example, we have some more QC things, and then a standardize that we're connecting to standardize our data. And then finally we have like our analysis results, which is looking for differential gene expression. And we're looking at each difference between the groups that were specified in our experimental design. And again, all of these have the interactivity to select points so you can get a significant gene list with your data.
Okay.
So that's a quick run through of JMP Genomics.
Thank you very much.
You're welcome.